Our story begins billions of years ago in the chaotic nursery of our early solar system. A young star, our sun, blazed with youthful energy, surrounded by a swirling disk of gas and dust. Within this maelstrom, gravity drew particles together, gradually forming larger and larger clumps. One such clump, destined to become our home, was the nascent Proto-Earth. Proto-Earth was a world in its infancy, a seething mass of molten rock and metal. It was a chaotic and violent place, bombarded by asteroids and comets, its surface a roiling ocean of magma. Volcanoes erupted with fiery fury, spewing lava and gases into the primordial atmosphere. The young planet spun rapidly, its days and nights a blur. This was a time of great upheaval and change, a time when our planet was still taking shape. But even amidst this chaos, a momentous event was about to unfold, an event that would forever alter the destiny of Earth and give birth to our closest celestial companion. This event, a cosmic collision of unimaginable scale, would shape the future of our world and set the stage for the emergence of life itself. While Proto-Earth was still coalescing from the solar nebula, another celestial body was taking form nearby. This object, roughly the size of Mars, has been given the name Theia by scientists. Theia, named after the Greek titan who gave birth to the moon goddess, Selene, was destined to play a pivotal role in the story of our planet. Like Proto-Earth, Theia was a protoplanet, a planetary embryo still in the process of formation. It orbited the Sun in a path that was dangerously close to that of Proto-Earth. Over millions of years, gravitational interactions between Theia, the Sun, and other planets in the young solar system gradually perturbed Theia's orbit, sending it on a collision course with Proto-Earth. The stage was set for a cosmic cataclysm, an event that would forever alter the destiny of both worlds. The idea that the moon was formed from the debris of a giant impact between Earth and another celestial body is known as the giant impact hypothesis. This hypothesis, first proposed in the 1970s, has become the leading scientific explanation for the moon's origin. The giant impact hypothesis suggests that Theia, on its unstable orbit, eventually crossed paths with Proto-Earth. The resulting collision was one of the most catastrophic events in our planet's history. It is difficult to imagine the sheer scale of such an event. Imagine two worlds, each a seething mass of molten rock and metal, colliding at unimaginable speeds. The energy released would have been staggering, instantly vaporizing vast amounts of rock and creating a superheated cloud of debris that would have enveloped both planets. This event, though long ago, left an indelible mark on our planet and its evolution, a mark that we can still see today in the form of our moon. The impact between Proto-Earth and Theia was not a head-on collision, but rather a glancing blow. This is crucial to understanding why Earth survived the encounter, and why the moon has the composition it does. Had Theia struck Earth directly, both planets would have been obliterated, leaving behind only a vast cloud of debris. Instead, the oblique impact sent shockwaves rippling through both planets, melting and vaporizing their outer layers. The energy released was so immense that it likely melted a significant portion of Proto-Earth's mantle, creating a global magma ocean. Material from both Theia and Proto-Earth was ejected into space, forming a massive ring of debris around the battered remains of our planet. This ring of debris, glowing with the heat of the impact, would become the birthplace of our moon. Section 5. From the debris, the birth of our moon. In the aftermath of the impact, the cloud of debris surrounding Earth was a chaotic and turbulent place. Collisions between fragments were frequent, gradually coalescing into larger and larger bodies. Over time, this process of accretion led to the formation of our moon. The moon's composition provides strong evidence for its violent birth. It is less dense than Earth and has a similar composition to Earth's mantle, suggesting that it formed primarily from material ejected from Proto-Earth's outer layers. The relatively small amount of iron in the moon's core also supports this idea, as the impact likely stripped away some of Theia's iron core and incorporated it into Earth. The birth of our moon was a defining moment in Earth's history, marking the end of its chaotic early years and the beginning of its journey toward becoming the habitable planet we know today. Section 6. The Aftermath, a Transformed Earth. The giant impact had a profound effect on the young Earth. The planet's rotation rate increased significantly due to the angular momentum imparted by Theia. This resulted in a much shorter day-night cycle than Earth had previously experienced. The impact also tilted Earth's axis, giving us our seasons. Before the impact, Earth likely rotated on an axis that was closer to perpendicular to its orbital plane. The impact knocked Earth off kilter, giving it an axial tilt of about 23.5 degrees. This tilt is responsible for the variations in sunlight that we experience as seasons. The giant impact was a defining moment in Earth's history, setting the stage for the emergence of life. Section 7. Lunar Secrets: Evidence of the Impact. The giant impact hypothesis, while compelling, would be just another theory without solid evidence to support it. Fortunately, there are several lines of evidence that point to a giant impact as the most likely explanation for the moon's origin. One of the most striking pieces of evidence is the moon's very existence. It is unusual for a planet of Earth's size to have such a large moon. In fact, most of the other rocky planets in our solar system either have very small moons or no moons at all. The giant impact hypothesis provides a plausible explanation for why Earth has such a large companion. The moon's size, along with its composition and orbital characteristics, provides compelling evidence in favor of the giant impact hypothesis. Section 8. Isotopic similarities: Echoes of a shared past. Another critical piece of evidence comes from the analysis of lunar rocks brought back by the Apollo missions. These rocks reveal that the moon's oxygen isotopes are nearly identical to those found on Earth. Oxygen isotopes are like fingerprints, providing clues about the origin of planetary materials. The fact that Earth and the Moon have nearly identical oxygen isotope ratios strongly suggests that they formed from the same material, further supporting the giant impact hypothesis. If the Moon had formed elsewhere in the solar system and been captured by Earth's gravity, as some alternative theories propose, it would likely have a different isotopic signature. The isotopic similarities between Earth and the Moon provide a powerful argument against capture hypotheses. The isotopic evidence provides compelling support for the idea that Earth and the Moon share a common origin, linked by a cataclysmic event billions of years ago. Section 9. The significance of the Moon: a stabilizing force. The giant impact that gave birth to the Moon was a defining moment in Earth's history, not just because it created our celestial companion, but also because of the profound influence the Moon has had on our planet's evolution. One of the most significant effects of the Moon's presence is its stabilizing influence on Earth's rotation. The Moon's gravitational pull creates tides in Earth's oceans, and these tides act as a brake on Earth's rotation, gradually slowing it down over time. Without the Moon, Earth's rotation would be much faster, resulting in much shorter days and nights. This stabilizing influence has had a profound impact on Earth's climate and the evolution of life, making our planet a more hospitable place for life as we know it. Section 10. The legacy of Theia: a part of us. The giant impact hypothesis is a story of cosmic violence and creation, a story that reminds us of the dynamic and ever-changing nature of our universe. It is a story that is still being written, as scientists continue to uncover new details about the Moon's formation and its relationship to Earth. But perhaps the most intriguing aspect of this story is the realization that we owe our very existence to a cosmic accident. Theia, the lost world that collided with Earth, is gone, but its legacy lives on in the form of our Moon and in the very fabric of our planet. The atoms that make up our bodies, the air we breathe, the water we drink, all of these were once part of Theia, a testament to the interconnectedness of our universe. Section 11. Conclusion: a universe of possibilities. The story of Theia and Proto-Earth is a reminder that our solar system is a dynamic and ever-changing place. It is a story that highlights the power of scientific inquiry to piece together the history of our universe and to reveal the interconnectedness of all things. As we continue to explore our solar system and beyond, we are sure to uncover even more evidence of past collisions and cataclysms. Each new discovery brings us closer to understanding the processes that shaped our planet and our place in the cosmos. And as we look up at the Moon, we can marvel at its beauty and remember that it is a lasting reminder of a time when our planet was young and a cosmic collision forever altered the course of Earth's history.